Great, thanks for that introduction. So the talk today is on the data services first approach and how that plays out in the cloud. My name is Eric Henham, as Rania said, and for MarkLogic, I've been with MarkLogic about almost 9 years now. I've worked on a number of APIs, REST API, Java API, Node API, Optic API, JSearch. You get the trend. So we'll start with the key principles of data services first, and that is to iterate on your applications, to integrate existing services, and to encapsulate the database. The point of iterating on applications is so that we take on one problem at a time. We integrate existing services because we're not typically able to work in a greenfield fashion. Typically, we have to maintain most of the ecosystem stable and innovate in a particular area. And finally, we encapsulate the database so the data model that's stored is free to change. And so generalists are able to work with the database without having to understand the technical details of how the data storage is implemented. So we'll look at a specific example, at the code for this, but we'll work through it in the scenario from the keynote demo. So in this scenario, we have an IT team for a health and human services department that's on the clock. They're trying to make real change in their environment, but they're working on borrowed time in two senses. First, the core team is pretty small. For most projects, they have to bring in contributors who are on project assignment. So by definition, those contributors are generalists. They can't expect those contributors to come up on, become experts in their approach. So that's one sense of borrowed time. The other sense of borrowed time is that they're struggling in their mission. They're perceived as a problem area within the department. And that's most visible in the call center. And the symptoms that show up in the call center include a caller might call in and the operator's not able to find the record for that caller. Or a caller calls in and the operator gives the caller the wrong answer. And all of this is adding up to establishing a bad reputation for the IT department. And what's particularly frustrating is that they're following industry best practices. They're taking a waterfall approach where it cascades from defining the schema for all of the data that they might need for all future applications, writing the ETL that populates all of the tables in the schema, and then writing the applications. And so not only is there a delay in time to value, because we have to do this schema design, and that has to be done very thoughtfully and anticipate all potential issues. And not only do we have to write the ETL as well, it's also a risk of fragility. So the root cause of the problem where the operator could not find the record for the caller was that that record was in a different data source. That data source could not be imported into this database because it didn't conform to the schema. The schema would have had to change. Changing the schema would have broken the ETL, would have broken the applications. The operators were giving the wrong answer to the question they were asked because the interpretation of the rules in the database was in an application in the middle tier. So it was very distant from the database, and when the rules in the database needed to be changed, no one was confident where the code interpreting those rules existed. So everyone was afraid to change the rules. So while this is a familiar approach, the team decided that rather than continue in a familiar approach that's not leading to success, Instead, the team would try a different approach and would have a cycle of iteration on rolling out applications. That cycle starts by identifying the first application, the application that's going to provide the most value for the least effort, integrating only the data needed by that application, ruthlessly scoping, so that even if other data is available, we don't integrate it. And then finally deploying in the cloud so that the infrastructure that supports our applications can evolve as the applications evolved. So Sarah and the team, Sarah the services architect, and the team get together and decide that the first application, the one with the most bang for the buck, will be a check on eligibility. And the way this will work is this is a pain point for the operators, and callers will call in, and based on their income and the number of dependents, the callers will be checked for eligibility. And the goals here are to improve the quality of service by improving the performance and improving the correctness. So the UI for this first application will be extremely simple. We'll just collect enough information to uniquely identify the caller, and then we'll run the eligibility check, and we'll see whether that caller is eligible, and in addition, see if there are other names that might be close matches so the operator can be alerted that they've potentially checked the eligibility for the wrong person. Now the application here is quite simple. The data model is quite simple as well. The data model consists of a person entity that has the information we need to match people and also to match them against eligibility rules, and the program entity that has the eligibility rules. Now, while the model might be simple, there's still data integration involved. And for the program information, we have to integrate information from two silos, from the energy silo, from the housing silo, and the energy silo. And for the person information, we have to integrate the information additionally from the military service history. So Darren, the data service architect, takes a look at this and feels that the scope is defined to be tractable. We're only integrating those two entities, person and program, but to prove it to himself, he takes a slice of data from each of these silos and manually integrates it and presents that to the team as the proof of concept. Sarah, the services architect, takes that proof of concept, and she's going to use that to develop in parallel as Darren is working out the ingestion and the harmonization to produce the data model for the applications. So when Sarah starts working on this, she's immediately confronted by the issue of what strategy she's going to use for database access. And she's worked with Java middle tiers before, so she's familiar with several strategies, and probably these strategies are familiar to many of you as well. I mean, the first approach is to embed the SQL in middle tier code with JDBC. The problem with this approach is that it encodes knowledge of the database schema in the middle tier, and that becomes a constraint on evolving the model in the database, because it's difficult to find the code that's affected by changes to the model in the database. And so you're at risk for breaking the middle tier. Sarah also knows of projects that have used object relational mapping. And with an ORM, the approach is to abstract the database. And we basically take a mirror of the subset of data we're interested in and turn it into an in-memory graph. The problem here is that the true cost of any operation on the database is really hard to see for the developer working in the middle tier. So what might look like a simple operation on the database might turn into a significant data transfer to and fro. And more recently, Sarah is aware of microservices and of some practitioners of microservices who take the approach of basically having a separate database for each microservice. That does solve the problem of how do we support change in the database by turning the problem on its head. Instead of having to deal with multiple services accessing the same database, each service has its own database. So the database can evolve freely to serve the purposes of that service. That's fine and good. The issue comes up when we need to integrate service or compose services. And at that point, we've thrown away what the database is good at. We have to do joins in memory and do aggregation in memory instead of taking advantage of the indexes and the hardened capabilities of the database. Instead, we have ad hoc code that's trying to do service composition and is at risk for breaking down. So Sarah decides that the root problem here is that the code that knows about the database is too distant from the stored data. So the solution is to bring the code to the data, to run the code that understands the stored data in the database. That way, this middle tier doesn't have to know about the schema. Knowledge of the schema is encapsulated in the code running in the database. In addition, the code running in the database can reduce the data before it's transported to the client. And as the model is maintained, so the code is maintained in parallel. It's really a bit reminiscent of object-oriented principles of encapsulation, where the stored data is understood by the operation that's exposed on that data. So Sarah's decision makes a change in the traditional three-tiered architecture. We still have the presentation tier at the top, the middle tier typically running on an app server, and the database tier. But the middle tier has changed. The business logic in the middle tier is really only in the top portion of the middle tier. And our data service is partitioned between the middle tier and the database tier. The interface to the middle tier, to the data service, is in the middle tier. The implementation of the data service is in the database. And that's what makes it possible for the Java generalist who's working in the middle tier to call the data service without having to understand the database. And instead, the database expert who's implementing the data service can bear the responsibility of making best use of the database. So in the MarkLogic approach, you can see that between those two roles, the Java generalist and the database expert, there's a collaboration. In the MarkLogic approach, that collaboration is captured in a JSON declaration. That's shared between the two roles. And the Java generalist uses MarkLogic tools that read that JSON file that has the contract between the generalist and the database expert. The MarkLogic tools reads that declaration and generates a Java interface. That Java interface is what the Java generalist uses. Now that generated interface is a thin layer over the MarkLogic Java API, which is doing the heavy lifting of unmarshalling and marshalling and transporting data to and from the server. The database expert takes the same declaration and, using MarkLogic tooling, generates a stub of an endpoint module. And the database expert then fills in that stub with whatever the data service is doing with the persisted data. So with that layered architecture in mind, and with the contract between the two roles, the Java generalist and the database expert, we can look at the highlights of some code now. So here is the endpoint declaration, the JSON file I was referring to a moment ago. And you can see for our eligibility checker, it has the eligibility of name identifying our new endpoint. It has parameters for the inputs for our data service and a return value for the response from our data service. The parameters are named and they have data types. The data types can be atomics that you might expect, date, time, unsigned, long, string, as well as documents, formats such as JSON document, XML document, and so on. Parameters can also be nullable, that is optional, and they can be multiple. I can send in multiple date times as the value of a parameter, or multiple JSON documents as the value of a parameter. The same thing is true with return of response from the endpoint. It can be any of the same data types. It can also be nullable or multiple. And parameters and return values can also have an annotation that's specific to the target. So in this case, we're generating an interface, a Java interface, so we can use a Java class annotation to tell the MarkLogic tooling how to represent the values of the return or of the parameter. So in this case, we're saying, when you give me back JSON documents, represent them as a JSON node from the typical Jackson library. So using MarkLogic tooling, the Java generalist generates an interface that looks like this. And you'll see that our JSON declaration has translated directly into a method signature. We have an eligibility of method. It takes those parameters. It returns that JSON node value. The factory up at the top merely takes a MarkLogic database client, so it knows what host to connect to, what port to connect to, and what the credentials are. The factory instantiates our housing services object. So when the Java generalist uses this housing services object, it's simply a matter of passing in the database client to the on factory and then calling the eligibility of function. So you'll note that the Java generalist doesn't really have to know anything about the database, how the database is accessing the data, executing the operation. For the Java generalist, this is just another library. It's a library performing an operation in the vocabulary of the data model, not a database access, not a database query. For the database expert, the tooling generates a stub that declares the parameters. Now these parameters, the MarkLogic app server, will initialize these parameters to those values that were sent from the client. So the endpoint developer doesn't have to worry about any of the housekeeping in working with HTTP. The app server takes care of all of that for the developer. So what Sarah will do with this is she will execute however many queries are needed to acquire the data she needs. Those queries could take the output from one query and provide that as the criteria for the next query. And she can reduce the data, can perform whatever calculations need to happen on the server to process the data, to produce the response to send to the client. And again, the app server does the marshaling of the response for consumption by the client on the middle tier. Now, so far, we've been focusing on the use of the declaration file as a signature for the endpoint. You can also use the endpoint file to control request monitoring. So Sarah is obviously concerned to make sure that her endpoint is meeting the SLAs. They have to prove the value they're delivering. What Sarah can do in the same JSON file, she can enable request monitoring. And now every request to that endpoint will have a separate entry in the request log, which is a new log added in recent versions of MarkLogic 9. She can set constraints to control what information is included in the file. In her case, she's interested only in the request time, the amount of time the actual request takes. So the list cache misses are not important to her. She sets the threshold very high, so that metric won't appear. In addition, this is an interactive request, so it has to complete quickly. If the request takes more than a minute, something is seriously wrong. So rather than have the request continue to consume resources in the database, Sarah can set a limit of 60 seconds, and the app server will automatically terminate that request, freeing up the resources, and Sarah can investigate what went wrong there. Okay, so having looked at some highlights, one more slide before we get to the real thing. So these are the entries in the request log that get generated if you turn on monitoring on an endpoint. And you can see our eligibility of endpoint is identified by the URI. And we have the request time here. And Sarah can see that most of the time, her request times are well under the SLA, but she does have some periods of peak traffic. So she'll adjust that, whatever way is appropriate. Maybe she needs to add more indexing, move the data, access the data out of a TDE index instead of from documents. Maybe there's an inefficiency in her query, but it gives her the feedback specific to this endpoint that she can use to achieve that SLA. Okay, and with that, let's look at some of this stuff in the wild. And so here we are, we're looking at Visual Studio Code, and this is the same JSON document we were looking at before, but the real thing, you can see the function name is there, the parameters, the return, the request monitoring, and I may as well expand, show, here's the collection of some of the metrics that are available to you. So you can see you really can get quite a bit of insight into what's going on in the particular endpoint. Here's the Java interface that was generated. Again, the eligibility of method is there, the on factory is there. So here's the code that the Java generalist wrote. And it's a Lambda for running on AWS. If this were a long-running process, the Java generalist might have considered a container, but this is an interactive process, so it has to complete quite quickly. It's going to be well under the Lambda limit of 10 minutes, so Lambda is a good choice. In the constructor for this Lambda, the database-specific parts start here at line 55, and let me scroll that up so that's visible further back. And what we're really doing, we're specifying how to connect to the database, and we're constructing our housing services object that has the data services for housing. And it's as simple as that to create our housing services object. When a request comes into the Lambda, AWS will invoke the handle request method, will extract the values of parameters out of the input, and we can do some validation on the parameters to make sure they're not null and so on. And here's where we make our call to the database, to the endpoint. And you can see it's a one-liner. So again, from the perspective of the Java generalist, this is an operation in the vocabulary of the data model. It's not a database operation. The Java generalist, as far as they're concerned, this could exist in any kind of system. It doesn't matter. So it's really performing a transformation on data from the perspective of the Java generalist. And as an illustration of how the database operation coexists with other operations in the middle tier, in our fictive story here, the Java generalist is creating a message if it was a successful eligibility check and putting that message out on the AWS SQS, simple queuing system, so that a legacy processor, maybe it's an audit processor, can pull the simple queuing system, get the message, and that way tie in this new innovative business logic with an existing system, just as an example of integrating existing systems. And you'll notice, again, these are both one-liners. Arguably, the data service is the simpler one-liner. And if I can successfully manipulate the mouse, here's the implementation of the data service endpoint. And we start by collecting the parameters. And we start our query. And this is the point at which Sarah gets to apply her database expertise. She has chosen to treat the optional parameters, the first name, date of birth, and zip code, with boost queries. So she's not going to filter out records that don't have the first name in case it was entered incorrectly. But if it is a match, she'll raise the ranking of that match so it pops to the top. And Sarah's also chosen to give more weight to the zip code than the first name on the premise that it's probably more selective, and more weight to the date of birth than the zip code, again on the same premise. What's worth pointing out here is that this is a fairly deep level of expertise that Sarah is putting at the disposal of the Java generalist, but the Java generalist doesn't have to understand it. And Sarah can refine and tweak this query without breaking the contract with the Java generalist. And let me also scroll down here and point out one other thing about the matching of the eligibility rules. So we've retrieved the program with the rules, and we have some scripting here that's doing the interpretation of the rules, that's matching the person against the rules in the program. And the point I'd like to make here is, again, that this is code running close to the data so that we can maintain that interpretation of the eligibility rules in the program as the program evolves. So we're not at risk of having our answers to the callers go out of date because the code that was interpreting the rules was distant from the data. And we get to the bottom. Sarah returns the response. The app server takes care of the marshalling of the response and returning it to the client. So Sarah stood this up using Data Hub Service. And we can see that Data Hub Service has a bog standard Data Hub framework with all the usual databases. So that endpoint declaration and Sarah's endpoint implementation are loaded into the Data Hub modules database. And once they're up, the data service is live and it can be called by the Java generalist. So I've filtered the modules database to just that eligibility of data service. Here you can see it, and you can see that the eligibility of declaration is there. The Java generalist builds a fat jar with with the generated interface and the Lambda that the generalist wrote, and loads that up into AWS Lambda. The generalist can then configure AWS API gateway to call that Lambda. And now the business logic is exposed as an application API available for applications. And when that Lambda is called, it will execute the Lambda, execute the data service that's part of the code of the Lambda. So let's do that. So we're going to post some data, test posting data to our AWS API gateway. And we're going to be checking eligibility on behalf of Mia Klein. So we run our test, and if my authentication hasn't timed out, thrills and chills. Okay, so here's our response from the server. It's the JSON document that Sarah's endpoint created. We did match a Mia Klein in Keene, New York. She is eligible. She matched the rules that she was both below the salary level and equal to or above the dependent level. But we also know notice there's another Mia Klein in Roswell, Georgia. So the operator can have the conversation with Mia to figure out which Mia it is. Well, that's a very revealing. I think I'm the third person in the last hour or 2 hours to say that they were defeated. They were able to deal with big data, but defeated by PowerPoint. Which I'm not going to bring up with David Gorbett because he had a role in PowerPoint. Okay, so to summarize the steps that Sarah and the team went through, they went through this cycle on their first application. They identified the eligibility application. They integrated the data, the person and program data for that application, ruthlessly scoping so that they didn't try to boil the ocean, didn't try to look over the horizon and anticipate the future. They solved today's problem rather than try to solve tomorrow's problem, because they know that when they get to tomorrow, tomorrow will have changed and they'll know more from solving today's problem. Anyway, they wrote the data service itself, loaded it up into the modules database, wrote the business logic as a Lambda on the AWS gateway, API gateway, and then wrote the application that consumed the API gateway. So the team is charged up, they're enthused, they're ready for the next, and they decide to do a fraud check as the next application. And that's when the bad news arrives. Because Darren, the data architect, takes a look at the person entity and decides it simply won't cut it for fraud. It's too simplistic. For fraud, we need to have identities for people. And some of those identities are suspect, but some may be benign. We may have someone who's known as Ace in their bowling league, but they have a different name in their work identity. And it's not because the person entity was incorrect, that was a mistake we should have foreseen. Every model is specific to a purpose. There is no such thing as an absolute correct model that's going to be valid for all future uses. And that's really where the waterfall approach breaks down. So Darren has been down this road before. He brings the news to Sarah, and he's a little concerned that he's made an enemy for life. But Sarah's not concerned. Because she knows, because the database has been encapsulated within the data service implementation, She reasons that she can take the last name and the date of birth, match the person with the date of birth, match the identity with the last name, join them together, group on the person, and produce the same return value that the client is expecting, and thus honor the contract. So if the model change can be absorbed within the data service implementation, the business logic doesn't have to change, the API gateway doesn't have to change, the application doesn't have to change. So with Sarah and the team well on their way to success, let's step back and take a look at how data services fits in the overall progression of MarkLogic client APIs. And really, MarkLogic has always recognized the value of executing code close to the data. The initial client API executed xquery, invoked or evaled xquery on the database. We introduced the REST API to provide standard endpoints for common operations on documents, reading and writing documents and querying documents. But the REST API always provided resource service extensions to make sure that a client of the REST API would be able to execute custom code close to the data. What data services adds to that story is the client interface and the marshaling and unmarshaling and the transport on behalf of the client interface. So where are we going next with data services? I mean, today data services are useful for interactive applications and for lightweight processes. But from our perspective, nothing makes a data service unreasonable to use for bulk jobs. There's no reason you shouldn't be able to send 1 million records and have them processed by a data service on ingestion doing exactly what you want on ingestion. Or when you're extracting 1 million records out of MarkLogic, there's no reason that a data service couldn't aggregate, filter, reduce, transform the data for you on egress. Or if you need to reprocess 1 million documents. Again, that should be possible to do with a data service. So we're enhancing the data movement SDK, which currently can drive standard REST endpoints over large quantities of documents. So the data movement SDK is able to call data services for those 3 scenarios: ingest, egress, and reprocessing jobs. But while of course the technology and the capabilities are interesting to us, what's really most interesting are the uses that people like you put the technology to. So I'm wondering, if you applied data services in your organization, so what would be the first application that you would pick that would provide the most value for the least effort and start that cycle of iterating over application development? What would be the services that you would integrate so that you could keep the rest of your ecosystem stable while you're innovating on the particular area of greatest value? And finally, if you encapsulate the database, if you take the data services approach of encapsulating the database, how would that free up your model to evolve to solve future changes? And how would it free you up to make Java generalists and other kinds of generalists in the middle tier more productive while expanding the value of your database experts? And with that, I'd like to open it up for questions.
Yeah, just raise your hand if you have a question. I'll bring you a mic.
Yeah.
Currently, the data service is primarily on Java. Is there any plan to support other programming languages as the client and invoke the data services?
Yes. So we do have a plan to support, or rather we have a target list of programming languages that we would like to support. The 4 languages that are highest on that list are C#, Python, and Node.js. But I would say currently for many of our adopters, much of their technology is on Java. So we want to make sure the Java story is complete before, instead of leaving it half-baked and moving on to something else.
So when you're planning to implement that, can the data service be defined using Java, but still the Python or any other code can still invoke the data service? Or should we have to do each language its own service definition?
So the implementation of the data service is, of course, on the server. So that's callable from any environment. And the endpoint declaration is in JSON. And again, that's in any environment. So what we would expect is that there will be MarkLogic tooling in the same way there is MarkLogic tooling that can read the declaration and generate a Java interface. There will be a MarkLogic tooling that can read the declaration and say, generate a C# interface. So you only will need to generate the interfaces that are of interest to you. And you only need, obviously, you will only write consuming code, calling code that's of interest to you. So really adding other clients is not going to be additional effort. Does that make sense? Yeah. Okay.
So the more follow-up questions
Okay,
on this
all
one
right.
is you're giving a port number here, right? So if you want to put a load balancer in front of it, so how does those things will work?
Okay, so data services like the Java client and the Node client today that are talking over REST, they use HTTP. Data services uses HTTP too, as well. So it can call through a load balancer just as easily as REST.
Any
Other questions? Question up here.
Just a couple questions. First of all, does the service endpoints, you showed JavaScript, could they be xQuery as well, or is?
Yes, so the service endpoints can definitely be xQuery. They both work.
I assume
Yeah.
that both would work. I just need focused on
Your
JavaScript.
assumption is good, yes.
Right, right. And then for the Data Hub service in the cloud, how does this data service extend to the cloud service?
Well, the example I
just-
showed you was executing against Data Hub service in the cloud. But it's not limited to that. Really, any MarkLogic server on-premise or in the cloud
Right.
has this capability.
Right, it's just, it's there built into the cloud service to do this data services if you add that.
Well, I would put it this way. It's built into MarkLogic server.
Right, right.
So if MarkLogic server is on-premise, it's available. If MarkLogic server is in the cloud, it's available. If it was provisioned by Data Hub service, it's still available.
So is this tooling only available for the REST-based endpoints which are based on the REST APIs, or can it be any REST endpoints?
Good. So the tooling is supplemental to REST. It is kind of, it can coexist with REST. You can put data services on the same app server as the out-of-the-box REST API, but you don't have to. Data services does not use REST. It's not RESTful. There's no notion of resources here, and it's not calling standard REST endpoints. It's calling an endpoint that you set up. So that eligibility of endpoint was an endpoint all by itself. It was not going through the REST framework in any way.
Mm-hmm. And when is this tooling available?
The tooling has been available since MarkLogic 905 or 6, I forget.
Okay.
So yeah, this is all what I'm showing today. We showed the prototype last year, and we're kind of, in our show and tell way, we like to brag about what we did over the years. So, so this is real live, has been so since August or September, I forget what.
Okay, thank you.
Anyone else?
Other questions?
So the data service is an application.
One,
The data service is an application instance on the MarkLogic server then?
The data-
Standalone, you define a port and
no,
parameters?
no. So the data service can be loaded onto an app server. Basically, any app server with a modules database, you can load a data, basically, you think of a data service as on the file system as a directory that can have many endpoints within it, each with their own endpoint declaration. That directory turns into a class in Java, or an interface in Java with a method for each of those endpoints. You just load that directory up into your modules database, and unless there's a rewriter that's intercepting traffic, you can hit those endpoints. You can actually have multiple, you can load multiple directories, each for a different data service, into the same modules database. So a single modules database could have 40 data services. Yeah, it's not a per port, not a per app server thing at all. They're much more lightweight than that.
Anyone
I
else?
see a question at the very back there on the
Oh,
left.
I didn't see that, thank you.
Am I right in assuming that this is not exclusively for AWS and could go with any other cloud provider?
Yes, in fact, data services, wherever you stand up your MarkLogic instance, you can put data services on it. So if you've got MarkLogic in the cloud on AWS, you can use it. If you've got MarkLogic in Azure, you can use it. If you've got MarkLogic on-premise, you can use it. I see a question at the far back on the right.
How do you do performance tuning? And if you have a query that is slow, how do you know it's not on the data service side or on the application side?
So the way you do performance tuning, one way you can get inspection of that particular endpoint is using that request monitoring I was showing earlier. Let me bring that up quickly if I can. Yeah. Wow, and now we've borked PowerPoint. Let's go out of, no, close the program. In the same endpoint declaration, I have control back. Okay. All right. We can show it here. Let me get to the eligibility of. Okay. So it's this monitoring thing here. In the endpoint declaration, the same endpoint it's not displaying. Okay, in the endpoint declaration with the function signature, you can turn on request monitoring. You can pick and choose the metrics, and then every request will put an entry in the request log, which is something new in a recent version of MarkLogic 9, and that will give you the metrics on that endpoint at the time of that request. So you can get a lot of insight. And this has list cache misses, it has request time, a whole bunch of things you can inspect to really analyze the specific factors that are affecting that specific endpoint. Okay.
Anyone else?
You can actually add custom log entries to the request log too, I should mention, by the way. Just embed them in your service implementation. Okay, well, I think our work here is done.
No, it's one more thing. Everyone, please make sure to fill
yes.
out the survey for this session. We appreciate your feedback. It only takes a moment. So do that as you step outside, and thank you for joining us.
Thanks for your interest.
Thank you, Eric.